vocabulary review. Okay, so okay, let's say we have a polynomial function. Let's just review. When I ask you for the zeros, what am I referring to?
Where it crosses over.
Okay, so where it crosses.
Over the x.
Right, so crosses x-axis. So my zeros are -3, -2, 1, and 0. Right? These are my 4 zeros. If I ask you for the roots, those are all the same thing. They're all the places where it crosses, and sometimes we have imaginary roots. So just a quick reminder, that's where when we set the polynomial equal to 0. So you could have imaginary.
So zeros and roots are the same thing.
Yeah. Well, okay, be careful. Could be imaginary. Here, I'll give you a quick example.
How do they do this?
Let's say I gave you a polynomial of x squared plus 4. Well, that's a parabola. We can graph that, right? But it doesn't have any zeros. Why? What's x squared plus 4 look like? It goes up 1, 2, 3, 4. Remember, it's got a vertical shift up 4 units. Yeah. Does this cross the x-axis? No. So this one has no zeros, but does it have a root? What happens if I set this equal to 0? I get x squared equals -4. So I get plus or minus 2i. So these are the roots, but there are no zeros. So I just want to be careful not to think that they're exactly the same thing. The zeros are where it crosses the x-axis. The roots in this case happen to be the same thing as the zeros because I didn't have any imaginary numbers.
So if let's say there's no, then the graph it doesn't cross the x-axis, then you
could still have some imaginary roots. Okay. Yeah.
Can you have imaginary zeros?
No. Okay. So zeros have to be real numbers. There's no I. Okay, factors. What's the difference between the zeros and the factors or the roots? Yeah, it's the opposite sign. So if -3 is a 0, x plus 3 is a factor. If -2 is a 0, x plus 2 is a factor.
Sign of 0 plus
yes.
X. What's the difference between the x-intercepts and like the 0?
That's the same thing. So x-intercepts are the zeros. Okay. So here we just write it with the ordered pair with the 0 here. That's all. Okay, so we're good with the vocabulary. So we want to solve the equation. We want to state the number and type of roots. So how many roots do we have? So let's just start with solving it, okay? Then we'll fill in the rest. So the first thing we want to see, does it factor? If it doesn't factor, we're going to go to quadratic formula. It does factor. So we get x plus 8, x minus 6. So I get x equals -8 and +6. All right, so there's, if it factors, we factor it. Okay, so that was solving the equation. Now we want to state the number. So how many answers did we have? We had 2 answers, and they were real roots. So 2 real numbers, right? We didn't have an imaginary number here, so we just say 2 real roots.
If it was an imaginary number, would you say?
We could, like, let's say one of them ended up being imaginary and one was a real, we would say 1 real root and 1 imaginary root. Well, they're specifically asking for the root.
Can you go back up a little bit
to the definitions?
So the roots and the zeros are the same?
The roots and the zeros could be the same, but remember I gave,
the same,
but
can't be imaginary.
I gave you an example where I did not have any zeros, but I still had two roots. They just happened to be imaginary roots.
Will we have that on a test?
Yes. That's okay. We're going to practice it. It's not, we only did one example. You can do some more and you'll see what I'm talking about. Yes.
How many more units do we have for the one?
Is it
No,
For the
the
test?
final?
No.
5?
The final we said
I
like
don't
5.
have a while.
Yeah, we have a while. I don't know. Offhand.
It's January.
Okay.
I have a question.
Yes. What's your question?
It's 256. Yeah.
It is a perfect square. Okay.
I just did the square root. I did plus.
Yeah, so 256
Then you
is
get
16 squared. And since it's x to the fourth, so I'm going to use the difference of squares. Are we okay with this? This is x squared plus 16, x squared minus 16. If I were to
X
FOIL
equals 4.
this, I would get back what I started.
Wait, but
So-
I did it different.
Okay.
I still got the same.
All right, so what I'm going to do is I'm going to set x squared plus 16 equal to 0, and I'm going to set x squared minus 16 equal to 0. Because x squared plus 16 doesn't factor anymore, but I can still set it equal to 0 and isolate x. So I'm going to take,
4i.
right, and one thing we don't want to forget, when we take the square root of both sides, we technically get plus or minus, oops,
Wait, x squared plus 16 doesn't factor in anything?
x squared plus 16 doesn't, x squared minus 16 does.
But wow, how come it's 4i and not just 4?
Because it's a square root of a negative. So remember, anytime we have a negative under the radical, it's going to have an I in the answer.
If you put x to the fourth under a radical, it becomes x squared, right?
Not a, yes and no, but you don't want to just take the fourth root.
I
Yeah.
think that's how. Wait, there's 6 different things for I. I thought there were only 4.
No, there's
she
only
just
4,
repeated it.
but she just started.
Yeah, I just started repeating. Okay, so when we take the square root of the other one, we get plus or minus 4. So how many roots did we end up with?
4.
4. Because don't forget, whenever we take the square root, we're going to get plus or minus. So in this case,
Also, the real
X
2
to the 4.
we had 2 imaginary and 2 real roots. Notice we started with x to the fourth power. That should let us know that we're going to have 4 roots.
But if it's negative 4i, would that negative I not become a negative 1? Or that would that? Oh no.
You answered your question? You got it? Okay. All right. So what does this mean? That means it has 2 places where it crosses the x-axis. So this graph crosses at positive and negative 4, but then it's not going to have, so it only has 2 zeros in this case, but that's not really what I'm asking. I'm just asking for roots. Okay. Notice this one is an x to the third. How many roots do you think? Okay. Okay, well, what can we do first? It's x cubed minus 6x squared plus 7x. I can take out an x first. And then can we factor that further? So think, what 2 numbers multiply together? Minus 7 plus 1. So from this point, I'm going to set each part equal to 0. So that's going to give me x equals 0. Good. So we have, did we have any answers with I? No. So there were all 3 real roots.
So do you just what do
So-
you say if you get I like answer that?
It would be imaginary. So remember how in the last one we got plus or minus 4i?
Yeah.
That was 2 imaginary.
The 2 real roots and 2
So this had 2 real and 2 imaginary. These were all real numbers, so I got 3 real roots. Just don't forget about the x equals 0, okay?
You have to use the cube method. So it's x minus 2.
Yeah, so remember, what's this formula? It's a minus b.
x squared plus f2x plus.
Wait, yes, you're right. So x minus 2, because 8 is 2 to the third.
What's that formula?
It's right here. I just wrote it above. And then x squared
There's 8.
plus 2x plus 4. So in this case, think, what's my a? Well, a is x, and b would be 2. So in the formula, I replace all the a's with x's and all the b's with 2's.
We just have to remember that formula.
Yeah, you just need to remember that formula.
Can we solve that second part by using the quadratic formula or factor?
Absolutely. So
Wait,
What if it was
2x and 4? Wait.
okay, so it's x to the third minus 2 to the third.
Okay. Oh, because 2, right?
Right, because 2 to the third. So b is 2. So x minus 2. And then a squared, that would be x squared, plus ab. So that means adding these two multiplied together. So that's 2x. Plus b squared. So what's 2 squared? 4. Okay, now I want to set each part equal.
What if it's like x to the 4 minus 8?
No. Then you'd have to solve that differently.
You can't factor x.
Okay, so I get x equals 2. That gives me one answer. But this doesn't factor. So if it doesn't factor, we have to do quadratic formula. Okay, so it's going to be negative 2
Is anything to the power of 0, 1?
plus or minus square root.
2 squared.
2 squared minus 4 times 1 times 4 all over 2 times 1.
Wait, why'd you put that in formula?
Because it doesn't factor. Because there's no two numbers that multiply together to give us 4 and add up to 2. Like I could try 2 and 2, but that adds up to 4. 1 and 4 adds up to 5.
Negative 12 in the right?
Yes, so we have 4 minus 16 under the radical. How would we simplify negative 12 under the radical?
2 radical 3i.
2i radical.
Good. So negative 2 plus or minus
2i.
2i root 3.
Is it negative? Oh, yeah. Turn it to negative 1.
And what do we notice? The 2 can cancel out, so that will be a negative 1 plus or minus I root 3. There was a negative under the radical, because remember it would be 4 minus 16. So again, anytime you have a negative under the radical, you're automatically going to have an I.
Is that 1
What's
imaginary?
the thing you do to take out the square and the what do you call for that?
To simplify the radical?
Yeah.
Well, did you do, you can either do a factor tree, but usually with square root of 12, what perfect square goes in? Square root of 4 times square root of 3, so
Oh, I see.
2 root 3. And then because of the negative, we just put the I in there. Okay, how many?
Outside, not the inside. It's 1 imaginary.
One, no, one real.
You can't have it. You can't have a 2 in the radical, right? It's not possible.
An I to that.
You only have an I outside the radical.
You said you can't have a 2 in the radical.
Wait, what?
You said you can't have a 2 in the
I said
radical.
I.
He said 2.
I heard I, but
No, the first after he said I, then the first time he was like,
I said I.
he was like, you can't have a 2 in the radical, right? The I has to be on the outside.
Maybe.
okay. All right.
This is very awesome.
All right, our last example, and then yeah, it looks like we'll have a good amount of time to get started on homework for those of you that have busy schedules these days. Okay, so notice in the last answer, when we had an imaginary number, we automatically had negative 1 plus or minus I root 3. Okay, that's always going to be true. Look, if we back up, anytime we had an imaginary number, we had a plus or minus. Okay, so that means anytime we have an imaginary number in our answer, so if a plus bi is an answer, a minus bi is also an answer. Okay.
So what is this? Like the conjugate of?
Okay, so now we're going to work backwards. I'm giving you the roots and we want to work backwards to find the original polynomial. Okay? Well, what did we do when we did these problems? What did we have to do? We had to factor and set equal to 0. What's the opposite of factoring? Multiplying. The opposite of factoring is dividing. Okay? Factoring is you're literally dividing it into two parts, right?
Yeah.
So it's the opposite of dividing.
Multiplying.
Multiplying. Okay, so if 2 plus I is a root, 2 minus I is also a root. So we want to write a polynomial of least degree with integral coefficients, meaning we want to get rid of all the imaginary numbers. So we want to get rid of I. Okay. So this is a little tedious, but if we take it step by step, it's not that difficult. Okay, if -3 is a root, what would be the factor? Positive 3. All right.
And the other one.
So the other one is going to be x minus 2 plus I.
Wait, no, what did you do? Plus minus, and also.
Okay, you'll see why I'm not going to. If you want, you could distribute the minus sign. I think it's easier to leave it. You'll see when I FOIL. So, and then, so are we okay with that?
Yeah.
Right? X minus 2 plus I. And then the other one's going to be x minus 2 minus I. Like that. I'm purposely using different colors so you can kind of see. This is the root, this is the root, it's x minus each of these.
Wait, so why did you make 3?
So this is gonna be
Why
hard
would
to
it be
do.
x minus?
Okay, don't worry about x plus 3, that's the easiest part.
Yeah, I
The
got
hardest part is this. So what I
Why
want
is
you
it
to
x?
do,
Oh, I think I got it.
because see, technically this would be x minus -3,
Yeah.
which makes it
Yeah,
x
you're
plus
doing
3.
X minus, yeah.
Okay, so, right,
So
if
if
this was a positive 3, x minus 3 would be the factor.
So if you had a thing that was like 2i, you would just do x minus 2i. And x.
Plus 2i.
No, I'm saying like other we see it. So you have x plus 3 and then it's oh yeah. That's right.
Okay, here's what I'm going to do. I'm not going to worry about the x minus or the x plus 3 for right now. I just want to focus on this. And I'm going to do FOIL. Okay. Following? All right. Foiling. Seriously? So, x times x is x squared.
Oh,
All right.
An I squared, therefore that's going to be a -1.
Okay.
Really?
Minus x times 2 minus I.
Yeah.
Right? Because I'm multiplying, so there's a subtraction sign.
be able to do this one.
That's so true.
This is the first time you've seen this. Okay? What did I say? If we finish the notes early, we can do some homework problems, and maybe we can do some of these for practice. All right, now let's do the inside.
It's my mom's birthday and I have a birthday. And I have a wait, no, I'm serious. Just thinking about I'm going straight from practice to the restaurant. The restaurant's super far away and I'm getting home at like 10 o'clock.
Okay, so stop talking and get to work. All right, and let's multiply the last.
-1.
So it's going to be plus, right? Because you have a negative times a negative,
Plus
and we have 2 plus I.
Half of these are letters.
Times
some is
new.
numbers. Bring them back.
Wait.
Okay, I just set up the FOIL.
Oh,
I
let her get
Why-
through it.
I
wait,
didn't.
Why do I do 2 plus I and 2 minus I? Why don't just Oh, okay. I see.
Wait. Is there a foil inside of that foil?
Yes.
So we're going to have to foil what we just foiled.
Yes, but it's easy because they are 2 plus I and 2 minus I.
Okay. Super easy. Guys, easy peasy.
Let's
Let it be.
leave the x plus 3 for the moment. Now, if we've done the setup correctly, all the i's should be eliminated. Okay, so let's watch. X squared. Now what? We're going to distribute the x. So that's going to be minus 2x plus I times x, or x times I don't care what order. Are we okay with that? Okay, distribute the next part. So minus 2x minus ix.
Plus 4 minus I squared.
Perfect. Plus 4 minus I squared. This is where
And I squared is 1.
this is where all the i's should be
I'm gonna be
eliminated.
plus 1. So we're technically plus 5. Just put plus 5.
So these we're going to cancel. Yes, you can think of that as a plus 1.
Or plus 5.
So we have x plus 3. And then this becomes x squared minus 4x plus 5. Okay,
There's so many spots to make this.
I know.
Now we can factor.
Now we multiply it out the last time.
And then can you factor that?
No, so we don't want to factor. Remember,
So we
what
get
did
back
I
to that,
say?
we get back to
When we did these previous ones, we were factoring.
Now we go.
We were factoring. We were dividing it up into smaller parts, right?
That's endless.
Now we're multiplying everything out. So we want to
Let's just factor this.
giddy. Now we're going to multiply this out. So we have x cubed minus 4x squared plus 5x plus 3x squared. Was there a question? Minus 12x plus 15. And then just combine. So x cubed minus x squared minus 7.
Don't that seem a little bit too long?
15.
Yeah, I would just want to make sure I have my signs right. Minus 7x plus 15.
Alright. Let's factor it.
Now, imagine I can't give you that many of these because see how long that took. It took a long time. But